Great, let's get started then. So thanks everyone for joining. Welcome to Robin AI's Future of Legal webinar series. My name's James Clough. I'm Robin's CTO and co-founder, and I'm joined today by two of Robin AI's machine learning engineers, Cristi, Burca and Cooke. And we're going to be discussing the fundamentals of machine learning, how we at Robin AI use machine learning in our products, in our contract platform. We're going to be breaking down the complexity, hopefully demystifying a little bit machine learning, exploring how a computer reads a contract, and discussing some ongoing innovations in the machine learning and AI space. Now, if at any point during the session you've got a question for us, you can submit it through the Zoom webinars Q&A function, and we'll answer them at the end if we've got time. So let's get started with some quick introductions of the three of us on the webinar today. I'll go first. So as I said, I'm James. My background was originally in theoretical physics and then moved into machine learning. Spent a few years doing research, sort of at the interface between the two, before co-founding Robin in late 2019. Emma, do you want to introduce yourself?
Sure, yeah. Hi. My background is that I'm a mathematician. I did basically maths all my life through undergraduate through to PhD, with a PhD in fluid mechanics from Imperial College. And then I transitioned from that to machine learning and started working for Robin, and I'm a machine learning engineer here at Robin.
Fantastic. And Cristi?
Yeah, hi. My name is Cristi. I'm the lead machine learning engineer here at Robin. My background is in computer science, and just before transitioning to ML, I was doing data engineering and analytics.
Fantastic. So to get started, let's start right at the start. The terms machine learning and AI, artificial intelligence, they're often used in a wide variety of contexts, often used somewhat interchangeably. I suppose to get started, what's the meaning of those terms exactly, or what's the difference between machine learning and AI?
Sure, I can take this one. So AI is the original term. I think it was first invented in the 1960s or maybe even earlier, and it basically encompasses any sort of algorithm that allows a machine to do something that seems human-like. So that involves chatbots, robots, self-driving vehicles, anything you can imagine. And machine learning is a more restricted term. It's a subset of AI, and it's any algorithm where you can that can work in context that so let me start again. Machine learning is any sort of algorithm that can work with unseen scenarios, compared to traditional software where you need to specify every edge case manually.
So it's about sort of learning from data, right, and kind of not necessarily writing down all those rules in advance, but sort of picking them up from unseen, as you say, from data sets and pairs of labels and data. And I suppose AI, it's something that's becoming a more and more popular technology, appearing in a whole range of different products. And I suppose people have a wide variety of perceptions of that, some of them positive, some of them negative. Why do you think that is, that diversity of viewpoints as to whether this is a good thing or a bad thing?
Yeah, sure. So I think AI is basically all around us. It's in our day-to-day lives, making things easier and just, I guess, adding value everywhere. So you might find that in like social media, your Alexa that's at home, your like marketing ads, auto-completing texts and emails, things like that, all sorts. And I think it's just a rapidly growing field that generally people didn't really understand a lot about, and probably people generally still don't really understand a lot about it, people that certainly aren't in the field. And I think it can be seen as quite a big black box. So you throw something in, and then you get something out, but people don't really understand, you know, why they get there. So there's been a lot of work, I think, over the past few years to really understand that, where these, you know, these things are coming from, because of the concerns that have been raised with, you know, certain biases that might get passed into your model from the data that you're training on, which we absolutely don't want to happen. So yeah, I think there's a bit of concern about that, rightly so. And I think the other thing is people tend to be a lot more forgiving when a human gets something wrong than when a machine gets something wrong. You know, we associate humans with just being correct all the time, and that's just not the case. So yeah, it's almost like your machine is trying to reach a level which you put the human on the pedestal for, and that's almost not going to be achievable. They're only as clever as we make them, right?
And I suppose it relates to that interpretability point you raised, Emma, that a person, they come to some decision, you can ask them why they came to that view, you can ask them to explain their reasoning, but a black box, harder to do that, right? As you say, some data comes in, some answer comes out, but you don't really have a way, unless you build one, of probing how that process, that decision-making process sort of comes to pass. So it's, you know, it's no secret that we use AI here at Robin. It's in the name of the company, of course. And Emma, you've been here since you know, for more than 2 years now, since almost the beginning. So what is it that we're doing with AI and machine learning at Robin? Why does it make sense for us to use machine learning in our contract platform?
Yeah, okay. Yeah, it's a long time since I joined. So when I first joined, I guess I wasn't aware of how many different ways a contract can present itself. The variety is huge, and basically, you know, a key point of when you would introduce ML to solving a problem is when you can't code the rules. And seeing the sorts of varieties of contracts that we have and the way in which our lawyers mark them up, because it's different for each client, they each have, you know, their own set of rules which need to be applied. Trying to code a set of rules to get this right all the time would just be impossible. So yeah, we can't write the rules, so we apply machine learning. And the other thing is we need to be able to scale quickly. So if our users are, you know, uploading contracts, I don't know, you know, tens of thousands of contracts or something in a day, depending on how big the client is, you need to be able to scale for that. And machine learning is great for that. So those are the reasons for applying a machine learning solution. However, you know, we know that the machine is not right 100% of the time. And so that's really important for us at Robin, is that, you know, we mark up our contracts to a really high precision. They need to be basically perfect. They need to do what a human lawyer does. And so we know that the AI is not going to reach that. So we have a human in the loop, or what we call it AI plus. So the human checks the result basically from the machine, which has done, you know, maybe done most of the work, maybe 99% of the work, and the human is just checking and verifying the results there. And so, yeah, the software is aiding the human with their daily work.
Great, and maybe all for you, Cristi, to delve into that a bit more. You know, we talked about certain tasks there that machine can try to get right or can learn from data. What are we talking about exactly here? What are the tasks that we're using that model to try to perform to help a person in their legal workflows?
Yeah, sure. So from the moment that a user uploads a document into our system, we do a number of things with it. The first thing is we look at the contract broadly and try to categorize it. Is it an NDA? Is it a supplier agreement? Is it some other sort of contract? That's step one. Based on that, we can kind of decide what we want, what we need to do with it going forward. So the second step is looking at individual paragraphs in the contract and trying to make sense of what's in that bit of legal text. So we call this clause labeling, and essentially you take a bit of text from a document and say, this is a definition, this is confidentiality exceptions, and I think we have dozens of labels like that. So that's step 2. And the first step is, after we know what a clause represents, we can try to extract certain key values. So for example, if it's a term clause, we can extract the duration in years. Or if it's a governing law clause, we can extract the location of the court that is relevant to that contract. So yeah, those are the 3 main things we use ML for.
Yeah, and for those who are watching our webinar yesterday, where we did a bit of a demo of some of the product, you will have seen those key values being extracted, those clauses being labeled. That's the process Cristi was just talking about there, that a document gets ingested into the system, it gets categorized, individual clauses get labeled, and then that identification of particular key values in those clauses is what powers that playbook-based editing system that allows you to, with just that one click, make those edits to change the meaning of certain clauses such that they agree with the set of rules or negotiating requirements that a user might have specified. So in terms of how we build that solution then, so machine learning and I suppose computer programs in general work most naturally on quite numerical data where numbers can be manipulated, but contracts aren't just full of numbers, they're full of words that need to be interpreted in some way. They're made up of text. So how does that work? How do we go about taking that document with the text it contains and turning that into some sort of numerical thing that can be analyzed by a machine learning algorithm?
Yeah, so computers still can only really deal with numbers. So yeah, that's a good point. Basically, we have a special step in which we break up a text into smaller bits, could be words, could be even smaller than that. And let's say we break it down by word. Then we have a method through which we convert each word into a series of numbers. You can call that a representation of words. And using those numerical representations, we can then train the model and use it after it's trained. So at the end of the day, yes, it's the numbers. We just have a clever way of converting text to numbers.
Great. So we get our contract in, we convert all those words into numbers, we put those through our machine learning model that we've trained with this data, and that helps power the rest of the software and helps sort of bring that process to life. Mm-hmm. As we're building that system, Emma, how do we know how well it's working? How do we measure success there? And what is it that we do to improve it?
Yeah, so as you just mentioned, we have this model that we've trained on a training set. We also have a test set of data, which the model has not seen before, so that we can track how well the model is doing on unseen data. So, there are various statistical metrics you can use to track how well your model is doing, to give you a measure of your false positives or your false negatives. And which measurement you decide to use basically depends on what problem you're trying to solve and what you're trying to optimize for. So that's kind of one of the steps. We also had a lot of feedback from our lawyers, like internally who are using the software. We have a lot of feedback from them as to how well the model is doing on certain types of clauses. And yeah, so anything that our lawyers have marked up is essentially fed into the model again and trained on this so that it can learn from more data. Essentially, the more data, the more generalized the model can be.
And so in that sense, right, yeah, it's a kind of iterative process where someone interacts with a software. They can either accept or reject that inference or those changes, and then that sort of cranks the handle to keep on making it better and better as time goes on. So that all sounds great, but are there any particular challenges that we've encountered so far, or something specific about the data that we've seen or we have to interact with from clients that's especially difficult or challenging?
Yeah, so I'll take this one, Cristi, unless you wanted to.
I'm sure there's plenty of challenges to go around for everyone.
Yeah, sure. Yeah, so a particular challenge is like rare outlier clauses within the data set. They can be the most important things to find, but we don't see many of them, and that can be very hard basically for the model to actually find these things. So that's a challenge that we have. And then, yeah, another one is to do with the kind of contracts that we receive. So what kind of format they're in, that can provide a challenge for the model, because the initial data might depend on how those sentences are processed, depending on how we receive them. So if we receive, say, an image, or, well, not an image, but like a scanned PDF, is very different from a machine readable PDF, those sorts of things.
Yeah, I think one thing that's very specific to legal text is that it's sometimes you have a very long and complex phrase. So even though the grammar is perfectly correct, even as a human, it's sometimes hard to understand what it's actually trying to say. So yeah, that's why we rely heavily on our legal experts to kind of help us make sense of these challenging clauses.
And those are challenges in terms of how we create those models and make sure that they're accurate. Are there any challenges or limitations that you've run into in terms of deploying those models as well and using them in real products that people interact with?
Yeah, so I guess one trade-off that we're constantly having to think about is precision or accuracy of the results and the model size. So usually the larger the model is, the more accurate it is, but it's also slower to use and takes up more server resources. So that's something we need to consider on a case-by-case basis, depending on what the product needs.
Yeah, that's a good point, isn't it? It's the sense in which, I suppose, even as people doing something close to the research side of things, sometimes an engineering side, you always have to be product focused and make sure that we're thinking about what's a user actually going to feel and think and do when they interact with the interface that we've built for them. So moving on then onto something a bit more future looking, or a bit of a broader question. There's clearly been a huge advance, or several huge advances, in machine learning technology over the past few years, in particular around natural language modeling. What are the recent advances or new technologies in this space that we make use of at Robin?
Yeah, so I'd say, well, maybe not quite so recent, but definitely, a game changer in the field is the idea of self-attention. So, attention models, they've been introduced in the past 5 years, and they've been crucial to the improvement of using or understanding natural language. But what do we use day to day that's kind of really helped us? I guess that's the ability to have and have access to pre-trained language models. So, it's only recently in the past couple of years that they've been so accessible. And that means that instead of having to train a model on a huge amount of data to make it generalizable, we can start from, a starting point, and then really have the model focus down on what it is that we want the model to get good at identifying. So for us, that's legal text. And so, yeah, our main part of the process is taking this generalized model and having it really understand legal text.
Yeah, so it's like we're not starting from zero. We're starting from a model that kind of already understands English to some degree, and then from there, it's a lot easier to make it understand legal English, if you will.
So yeah, just has to do the sort of that final step rather than all of that process that you spoke of earlier of learning how to turn words into numbers in a useful way. We kind of get that for free, and then just need to focus on the tasks at hand that are especially relevant to us and to our products. So these sort of pre-trained language models, these large language models, as they're called, been a load of hype about them over the past few years. People might have heard of GPT-3 or other OpenAI products that are out there now. They've been used in a really wide range of applications. Can you briefly explain what is it about those? Well, firstly, what are those big models for those who've not heard of them? And is that something that could be a useful technology that we use going forward, those really large generative language models?
Yeah, so GPT-3, basically, as you said, is a generative language model. And so that model was trained to predict the next word in a sentence, essentially. And so it was trained on a supercomputer on almost the entire internet. So it cost an awful lot of money, millions, I think it was like 12 million. And this means that the model can generate basically human-like text within a matter of seconds. So it's very impressive. And that's great, but the model is very general for solving, various different tasks. And so so for the latter part of your question, James, as for how useful that would be for us, we would need to focus on really tailoring that model to something specific that we could use, and also, which would take time and resources, and also the way that we would deploy it as well, because as Cristi said, these models are massive, and deploying them in itself is a task.
Yeah, I just want to add on that yeah, people kind of paid attention because it seemed almost as if the model was sentient, but that's not actually the case. It's just really, really good at generating text that sounds like proper English. But it still often happens that if you change just one word in the input you give it, it does something completely unexpected. So yeah, I think we might be able to use it for maybe augmenting some of our existing models, but yeah, we wouldn't just use it straight out of the box.
Yeah, I suppose that's the challenge with using those big generative models in the legal industry, is that you don't just need something that at a surface level looks like it's grammatically correct or interesting text. You need something that is very precise and means exactly what you need it to. That sense of variability and uncertainty that can be useful in, there are applications where that's really valuable. I've seen these models being used really successfully in generating advertising copy, for example, where that sort of variability kind of feels like being quite creative and generates lots of different possible ways of explaining something, and then somebody can pick the version that they think is most appropriate. Maybe the opposite to what you want in the legal case, where it's about giving the pedantic exact version of a sentence that means precisely what you mean it to, and being a bit creative and exciting isn't always what you want there. But I think you're completely right, Cristi, that there are still places or applications where that can be valuable. It's just about deciding where in your kind of the sequence of steps that we use to provide a good end result to a user is the right place to slot in this kind of really, really powerful model. I suppose the other direction in which there's been some innovation over the past few years that has certainly played into the work we've been doing at Robin is around sort of cloud services and sort of deploying models in a way that's much easier, much sort of less resource intensive from a DevOps side of things. What are your thoughts on that? I mean, I know that's something we've certainly been looking at over the past few months here at Robin. Do you think it's something that's likely to sort of increase or open up ML adoption, innovation, and seeing machine learning applied more widely in products?
Mm-hmm. Yeah, Emma, I think you're intimately familiar with the various options by this point. Yes, I think one challenge there is latency. So you can have a model that's deployed and it's kind of not using any server resources, and then it gets spun up just when you need it, and that saves costs. But then you lose a few extra seconds, or maybe even longer, to get that model loaded and ready to do work. So I think that's one of the challenges.
Fantastic. So I think to start to wrap things up before we take any questions, are there any new technologies kind of on the horizon that we might not have used yet here at Robin, but you can see breaking through over the next few months or years that could be an exciting proposition for us to integrate into the work that we're doing, and the machine learning team more widely here are doing?
Cristi, do you want to take that one?
Oh yeah. So I think one we kind of already discussed, which is these really large models. Essentially, they're kind of the same as the type of models we're already using. They're just massive. So that's one thing. I guess the other thing that's come out in the last few years as well is specialized chips for machine learning. So you have chips in smartphones, particularly iPhones, have something specifically for processing images and so on. But we're also seeing dedicated chips from the cloud providers, both for training models and for doing inference in a cost-effective way. And that's something we definitely want to use as much as possible.
Yeah, I'd just add that maybe this is like personal opinion, but I think that we will probably always need a human in the loop, like at least for, I don't know, at least for the next decade. I imagine that we're going to need that, because we need to be so precise with the way in which we mark up our contracts. But as Cristi mentions, there's being so much, money piled into resources to make people interacting with AI services much easier, like just the availability of models, and then also, yeah, as Cristi said, the chips, different types of chips that supporting machine learning models.
I mean, maybe to just explore that point you raised there, Emma. I mean, what's your view on that, Cristi? Do you think that there are certain tasks that we have a human in the loop for with our AI today that will one day be able to transition to being a purely AI approach, or do you think there's always going to be a need for a person in the loop in the legal sector?
Mm-hmm. Yeah, so actually, I've been thinking about this today, actually. So for contract, so for editing of a contract that comes in, we might be able to automate it completely if it's the same contract that comes in multiple times. So say you have, I don't know, an employment agreement, for example, and it's just from the same template. We could be fairly confident that the edits we make will be appropriate, because it's the same client, it's the same sort of contract, and it's actually the same text. So yeah, I think a good part of the current manual work can be fully automated, actually.
Yeah, I think that's a great point about how, even more generally, you always have to be quite product focused, I suppose, and think about the way in which the traditional machine learning pipeline or paradigm doesn't necessarily always fit into the way that you actually need to work. And so, for example, people are always concerned in most scenarios, rightly, about making sure their model generalizes, that the test set and the training set are very separate, and we need to make sure that the test set that we've never seen before is the performance. We're trying to optimize for performance there. But you're completely right, Cristi, that sometimes in reality we do see the same data again and again and again that was in the training set actually coming back in real life several times over, and so we can, in that situation, be really, really confident, and we might be, or be normally considered overfitting, but if we can get an incredibly accurate or 100% accurate result on some data we've already seen before, that might actually be, from a customer's point of view or from a user's point of view, a fairly large fraction of the interactions that they have with us. And so being able to identify those situations where we can say, hey, this isn't a problem over which I need to generalize, this isn't new unseen data, this is something over which I just need to apply a tried and tested strategy, is it's a way in which it kind of deviate from that standard, slightly academic way of thinking about things, and be a little bit more focused on the end user, I suppose.
Yeah.
Cool. Any thoughts there, Emma? Are you firmly on the we'll always need people in the loop side of the fence?
Yeah, no. Yeah, I agree basically that there will be, there are things that we can completely automate, definitely. Yeah, just not everything.
And are there any moving on to questions now, are there any challenges in particular to applying machine learning in the legal industry specifically that might be new to people who've worked in NLP but not in the legal sector that you've encountered so far, Robin?
Yeah, sure. So I think, well, one of the first things that exhibited itself to me, which is definitely, I think, legal specific, is that lawyers want to minimize red line. So this is kind of the amount of text that you decide to replace in your contract. Yeah, in the beginning it wasn't apparent, like if we find the clause, that's step kind of one of the problem. Step two is, how do we actually mark up this clause? And you could say, well, let's just take the whole text and let's replace it with something which we know is right. Lawyers don't want that, because they don't want a large amount of what they call red line within their document. So that then added this kind of second layer of how do we approach that problem in order to mark up the contract with minimal red line. So I'd say that's one that we're still working on, but we're definitely getting better at it. And then I'd say the other one, which is still a challenge, is that what one legal person might think is, either a particular clause name might be different to what another kind of legal person might think that clause is. I'm not going to try to give an example because I think I'll just give a really poor one.
But that sort of idea of there being a bit of subjectivity in what the right answer is, makes
exactly.
It,
so you might show, you might show one person one result and they think, oh, that looks great, and then you might show another person the exact same markup and they say, oh, but that's missed this thing which I really care about. So I think that's a challenge.
Yeah, I mean, I think that first point you raised as well is one that we see even beyond just the machine learning side of our software. The fact that legal it's not just a industry where you're trying to help one person in isolation do their work and that's the end of it. There's actually this, it's a necessarily adversarial dynamic sometimes. You're editing a contract or you're reviewing a contract because you're negotiating with somebody else, and so you need to think about not just how the user you're trying to help will sort of interpret the changes that you're making or provide data for your software. You also need to think about how they're going to interact with their counterparty, someone who you don't know, who doesn't use your software, who doesn't necessarily trust your software. That's always been, I think, a big challenge, an opportunity, but still a challenge for developing software in the legal sector, that you need to be compatible with various ways of working and various bits of software that aren't those that your customer's using. And you can't always just win that battle with sort of brute force or even with a superior user experience, because this person who you need to get on side doesn't necessarily use your software as well. Maybe one final one then before we finish. I suppose a question that relates to what we just discussed, which is what to do if you can't easily access large amounts of data to train your model. I mean, I think that's definitely a particular restriction that we see a lot in the legal sector, because data is often very confidential, right? People aren't willing to just hand over all of their signed contracts with all of their, the agreements their business has made, and that lack of data can make it really challenging to train models effectively. Cristi, how does one get around that really fundamental issue?
Yeah, so it's a good point. Even though we have a lot of contracts that our legal team has very diligently labeled, some clauses are just very rare in contracts, but nonetheless we need to handle them and to know what to do with them. So yeah, it's definitely an ongoing challenge for us. And the short answer is that there's a whole research subfield dedicated to this. And fortunately, there are a lot of methods that we can use to make the most out of the limited data we have. And pre-training is definitely a big part of that. But on top of that, we have various advanced techniques to really eke out all of the information from our training data.
Yeah, I think that's just a sort of inherent and ongoing challenge of working in this space. But I suppose that's also where a competitive advantage can come from if we get things right and build the right techniques, build the right models there.
Yeah.
All right, let's leave it there then for today. So we've come to the end of the session. So thanks so much for attending. Hope you found it useful and a good insight, if a brief one, into some of the work that our machine learning team, Emma, Cristi, and everyone else here at Robin is doing to build the software that makes contracts simple and that uses AI to help automate and assist some of those complicated legal workflows that we've been working on over the last 2 years. So there's going to be a recording of today's session that'll be shared with you if you're attending today, also available on our website. And we've got one more webinar happening this week, so do sign up for that if you haven't already. It's at midday tomorrow, and it's going to be, so it's the other side of the coin. It's our legal experts are going to be sharing some of their knowledge, in particular about the ways they use Microsoft Word, or the Microsoft Word hacks, I think they would say, that they've had to learn over the years that hopefully as a result of our software becoming more prevalent will be things of the past. You won't have to learn how to hack your way through Microsoft Word to do what you want to do with your contracts anymore, because Robin is going to do it for you. But you can learn about those problems and the solutions that we're developing for them tomorrow. So please visit our website, robinai.co.uk. You can register for that webinar. Yeah, happy to leave it there for today. So thanks so much, Emma. Thanks, Cristi, for your time and for your insights.
Thanks everyone.
Hope you guys enjoyed it. And yeah, thanks for attending, everybody.